I'd like to introduce our speaker today, Dr. Richard Hipp. Richard is the primary author of SQLite, which most of you have heard of, presumably. It's a small open source relational database engine that has really skyrocketed in popularity in the last 4 or 5 years. It seems like pretty much every week or two I hear about a new project either inside Google or outside that's using SQLite. So we're real happy Richard's been able to join us today to tell us more about it. I'll also mention this talk is being recorded and it'll actually be available externally. So if anyone has any questions that involve information confidential to Google, please wait until after the talk to ask Richard individually. Great, so without further ado, Richard Hipp.
Hi everybody, my name is Richard and I wanted to give you a brief talk on SQLite. I understand that we have 35 to 40 minutes, so I can't go into a lot of technical detail. I'm going to give you a high-level overview. Now, the way this normally works is that I have these slides here, which, if we're lucky, will be roughly correlated to what I'm going to be saying. But I must have hit the wrong button here.
What you want to do?
There we go. Got it. Got it. So, are you left-handed?
I'm not left-handed.
Okay.
I'm right-handed.
That's what got me confused. All right, so I just want to give you a brief talk about what SQLite is about. We don't have time to go into the technical details. I'll show you a little bit of the API maybe, but really to get into the technical details, that takes way more time than we have. So I'm just going to give you a brief introduction to the motivation behind SQLite, what kind of problems it tries to solve, who's using it, and at the end I want to give you some general lessons that I've kind of picked up in doing this project, which are applicable to a lot of different things. I'm going to need to reduce the resolution a little bit because we're off screen. What's the best way to do that? There we go. That's better. So what is SQLite? It's an SQL database engine, but it's a little bit different. Most people hear SQL database engine and they're thinking Oracle, something big that you run your whole enterprise on. SQLite is sort of the opposite of that. It's trying to be very small, so that it's very compact. Some of the features. It's designed to be embedded in applications or in hardware. It's serverless. It writes directly to the disk drive as opposed to sending IPC to a server that takes care of storing things. Very small footprint. Fully configured, it's less than 250 kilobytes in size. Generates small databases. Has a lot of interesting features. It allows you to define your own SQL functions that are just C functions, or your own collating sequences. So if you're working in languages with an unusual collating sequence, you can accommodate that. The database file, the entire database fits in a single source file. And when it's a cross-platform source file, the entire database fits in a single disk file, which is a cross-platform. So you can write the database on a big Indian machine and then just copy it over to a little Indian machine and it works fine. So it's been picked up and it's being used quite a bit. It supports a big subset of SQL. It's really easier to tell you what things it doesn't support. The biggest omission right now is that there's no support for foreign keys. Well, it'll parse them. It'll parse a references clause. It just won't enforce it for you. There's some alter table things that it doesn't quite do. There's some trigger things that it doesn't quite do. Write and full outer joins it omits. You can't write to a view. And some people get really upset that you can't grant and revoke, but that doesn't really make sense on an embedded database. We're writing to a disk file. If you can read and write the disk file, then you can do anything you want by just doing fopen, and so what would grant and revoke really buy you? But it has all the other features, and in particular, it gives you atomic or ACID transactions, which is a very important feature. Now, who's using it right now? It's out there, it's public domain, so lots of people are using it that I don't know about. Every now and then I'll hear about somebody new that's using it. Here's some of the few icons that I collected recently. I'm told that Solaris 10 will not boot without SQLite. Firefox obviously uses it. Symbian's putting it in their operating system for cell phones. AOL, it's the CD-ROMs you get from AOL that 1,001 hours free. It's got SQLite on there. It's built into PHP. Some people are using it in ways I don't know, like General Electric and Toshiba wrote to me and asked, what is the U.S. export control number for SQLite? So presumably they are using it in some way and exporting it, but I have no idea how. It's used in Yum. Monotone uses it. Monotone is a configuration management system that was it was kind of the inspiration for Git, which is what the Linux kernel is using now. So, and then I've seen some question marks up there. A lot of companies come to me and they say, hey, we want to talk to you about SQLite, and then I sign a non-disclosure, and then they tell me that they're using it. So, but because I signed the non-disclosure, I can't tell you, unfortunately. So what's it good for? Now, a lot of people, as I was saying earlier, a lot of people, they hear SQL database and they're thinking Oracle, run your enterprise on it. SQLite's really not designed for that sort of thing. I've got a number of reasons, a number of things that you can do with it up here. And I've kind of broken them up into two categories. There's a few uses up there that are the kinds of things that people normally think about using an SQL database for. And then I've got some other ideas down here that SQLite is good for that people who have done SQL for a long time don't normally think of, because these other four reasons down here, a client-server enterprise database doesn't do these things very well, and so people don't normally think about those kinds of things. But let me just briefly go over some of the uses that you can use for SQLite. Well, you can obviously use it for anything that you can use a client-server database engine for. Just, you know, substitute SQLite for the client-server database. Now, this has a number of advantages. You know, it just works. There's nothing to configure. You don't have to get with your Oracle DBA to set up an account and all of that. And you can run it off a CD-ROM, for example, which is a really popular thing for people to do. But it also has some disadvantages. Because it's a small embedded database, you don't have the scalability that you would have with a client-server database engine. It doesn't work on does not work well on a network file system, simply because network file systems are kind of slow. I've used SQLite with up to about 30 or 40 simultaneous clients, but if you go beyond that, that's about it. It's not going to scale to 1,000 simultaneous clients. And it doesn't go into terabyte-sized databases. On the other hand, a lot of people are using client-server database engines in situations where SQLite would work just fine. They're not using the full power of their enterprise database. So this is sometimes a useful thing to do, though it's not really what it was designed to do. Another thing that's really useful for SQLite is to use it as a stand-in for your big client-server database during testing or demonstrations or development, where you don't want to have the hassle of setting up the big client-server database. You can just plug in SQLite as an alternative, and you've got a generic database interface layer. And this actually works very well, because then your developers don't have to mess with administering your database. They can focus on working with your product. Another thing I've seen people do with it is that they'll have a large enterprise database, and their application needs to download a significant or some subset of that database. I mean, you know, maybe it might be small compared to the total amount of information in that database, but it's still a large chunk of database. And so what you could do is pull that down off the main database and cache it locally in an SQLite database to improve performance and reduce the load on the enterprise database engine. But then we get into some of the things that you wouldn't normally think about using a database for, such as what we find SQLite is very useful for is just a way of implementing complex data structures in generic applications. When you've been working with SQL for a while, you find that it sort of changes your way of thinking. SQL allows you to think at a much higher level, in the sense that you don't have to worry so much about how you're accessing the data. You just tell SQL what data you want to access. And this, especially with scripting languages, this actually plays very well. You can embed SQLite in your application, and instead of building some hash table or using some B tree to access your data, you just store it all in a database, and then you do a query to pull the data out that you need. And depending on what your application is, this can work really well. I know I did a quick little application for Duke Power, where they had this big glob of data and they needed to sort it 15 different ways. And so it was really simple just to load all the data into a database and then do a query for the whole thing with a different order by clause depending on how they wanted it sorted. And that was a whole lot easier than trying to load it into a linked list and doing a merge sort on it. SQLite is very good for persistence of objects or for configuration files. I guess, in the Windows world, Windows wants you to put everything in the registry, but you used to have all these INI files lying around. You still have a lot of little configuration files in the Unix world. And SQLite is a very good place to store that sort of information. This is a goofy use, but it actually comes up. Sometimes you have a couple processes that need to talk to each other, and you're writing an application that needs to work on the lowest common denominator, which by that I mean the only thing that you can really count on having available to you is disk I/O. Any other type of IPC may or may not be available. So you can use an SQLite database as sort of a chalkboard to exchange information between processes that would not otherwise be able to communicate. The most important or the most interesting thing that I like to see SQLite used for is as an application file format. Suppose you're running a new application, and what most people do is, by application file format, I mean something like an XLS file for Excel. Or imagine if you were writing something like a GNU cache, a financial management program. You need to store everything in a file like that. SQLite makes an ideal use for that. Usually what people do with something like this is that they will create their own file format, and lately the trendy thing to do is to make it XML, but oftentimes it's something customized, and then they'll write their own parser for it, and then they'll have to read it in, and this sort of thing. And that's a lot of work, and you can do that. But instead of doing all that, and when the user selects File Open, just connect to an SQLite database. Now you can give it any extension on the end that you want. It doesn't have to be .db or something. It can be whatever's appropriate for your application. The end user doesn't need to know that it's an SQLite database. It's just a file to them. But this way, your application load connects to it. You've got all the features of a relational database engine. You've got atomic commit. You've got durable transactions. You've got great ways to accessing the data. You don't have to load the entire thing into memory all at once. And if you've got a particular application file format that is going to be used by multiple applications, sort of a common file format, these multiple applications can be written in a large variety of languages, because SQLite can be used from various scripting languages, programming languages, and they'll all read the same format without having to everybody having to write their own parser and translator. So that's some of the uses that we like to use SQLite for. If you're interested in working with this, it's really easy to get started using SQLite. Just go to the website, which is up here, and there's a standalone executable that you can download, put it on your PC, and then just run it. And you give the command line, it's a command line thing. You just start up this little executable and give it the name of the database file. If the database file doesn't exist, it'll be created. And then you start typing SQL. There's no administration to set up. You don't have to set up passwords. You don't have to allocate space. It's there for you to work. I know that a lot of university faculty use this in teaching beginning SQL courses because it's just something they can give to the students and it just works. There's nothing to set up. If you want to start programming with it, what gets shipped is basically a C++ API. And we've got 8 basic interfaces here. Now, this is a simplification. A lot of these interfaces really have multiple versions to accommodate different data types. But at the top and the bottom, you open and close a connection to a database, and this gives you a connection. And then you prepare your SQL statements. You can bind parameters to the SQL statements after you prepare them if you want to. Then you step through the SQL statement. You can use the column commands to access data. And then you can either reset to run it again, or you can finalize it, which is the destructor for the object. Here's sort of a quick example of how you would use SQLite in your program from C. And once again, this is not real code. This is pseudocode. The interface is actually a little bit different, but you can read about the details on the website. So you open a database file and it gives you a pointer to an opaque object, which is your connection. And then you can call prepare to prepare an SQL statement. And in this particular example, I've got the colon X on the end. That's a variable that you can bind to it. If you don't bind anything to it, it's going to think that's a null. But on the next statement down, we're saying, well, we're going to bind to colon X the value 5. And then we go into this while loop, and we're stepping through the statement. And for each, as long as the step function returns is not returning SQLite done, that means there's a new row of result. And then we can access the result and print out the result there. And then after we've run through that, we can reset the statement. And then we're going to run that same statement again without having to re-prepare it. But I can change the binding on X from an integer 5 to the string hello. And so now I'm going to be doing a little bit different statement. I do it again, and then I finally finalize the statement and close the connection. That's the basic C API. Most of the other bindings tend to mirror that approach. I wanted to show you the Tickle interface, though, because it is a little bit different, and it has some ideas that I'm trying to get people to adopt. In Tickle, if you were going to use this, what you would do is use the command SQLite 3 to create a DB object. So DB is now an object, and it becomes a command, and you can invoke it at various places. And then I'm going into a loop here. I've got some list of values that I want to insert into the database. And the for each loop will execute once for each element of that list, setting the variable term to be one of the values. And so then I'm calling this method eval on the DB object, and I'm giving it an insert command. And out at the end, I put a $ term. Now that's one of those bound variable things like we saw before. That's like in the previous example, it had a colon X. If it's in, I think SQL Server uses an @ sign and then the name of something for a bound variable. ODBC uses a question mark. SQLite supports all those different forms, but in this one we're using a $. And what happens is that SQLite sees that that's a $ term, and it goes into Tickle and says, well, what's the value of the term variable here? And actually uses that directly. So you're not making a copy of the variable. There's no chance of SQL injection attacks or anything like that. You don't have to quote it. If term was a blob that was 10 megabytes in size, there's no extra copies made. It uses it directly. And also, SQLite, the Tickle interface automatically caches the prepared statement, so that if we were going to do this loop 10 million times, it would only do the prepare once, and then it would just reuse that statement multiple times. And that's all taken care of automatically. There's nothing that you as a user have to deal with. The other thing, down here below, we've got an example of extracting information using the interface. Once again, I use the db eval method, and then I put a little script after it. And for every row in the result set of this table, it's going to it's going to create new Tickle variables with the name of the column that contains the value of that column. And in this particular case, I'm just have a single column in my result set A, so it creates a single variable A and initializes it to the value that's extracted. All of this to point out to you that most of the interfaces have this elaborate system that emulate the C API, where you have to prepare and then bind and then step through it and then and so forth. It's a lot of work to do. Here's an example of an interface that brings the SQL very close to the programmer, so that you as a programmer or whoever's using it don't have to think about how to operate the database. You can spend more of your brain cycles thinking about how to solve the problem you're trying to solve. It fits very naturally. Unusual features of SQLite. The most controversial feature of SQLite is that it tends to ignore data types. This is not entirely true. In traditional SQL, you have to specify a particular data type for each column, and it doesn't let you put things of different data types in that column. SQLite allows you to put anything you want in any column you want. So if you declare a column to be of type integer and you want to put a blob there that's 10 megabytes in size, it will let you do it. Now, I call this manifest typing. If you're programming, I think Ruby calls it duck typing. If it looks like a duck, it quacks like a duck, it walks like a duck, it must be a duck. This is very much inspired by scripting languages where things operate. You can put values of any type you want into a variable, and it just keeps track of it. Now, to maintain compatibility with other SQL database engines, SQLite has this idea of type affinity. If you declare a column to be an integer, and you try and put a string into that column, and that string looks like an integer, it'll do the conversion. Now, if the string doesn't look like an integer, if it looks something different, it won't convert it. It'll store it as a string. But it tries to convert it to an integer if it can. Likewise, if you take an integer and you're trying to put it into a column that's a var car10, it will do its best to convert that integer to a string, which it can always do, so it will always do the conversion. If SQLite also allows you to declare a table with columns that have no type specified at all. And if that's the case, it makes no attempt to do any conversions ever and just takes and stores whatever type that you put into it. This is, I consider this a feature of SQLite, though there are certainly no small number of people who consider it a bug. Another unusual feature is the way that we store the database schema in SQLite. There's a single table called SQLite Master, and it basically stores a copy of the original create table statements that established the schema to begin with. So this table is normally read-only. You can query against it to find out what you need. There's a pragma that you can throw that you can actually write this table, though if you write to this table and you can pretty easily corrupt your database that way. So if you want to get schema information out of SQLite, you just do a query against the SQLite master table. The first one there is getting a list of all the tables. Select the name from the SQLite master table where the type is table, and then order it by name. And down below you can get the original text, for example, of the create table statement for a particular table. Another feature of SQLite is the ability to talk to multiple databases simultaneously. There's a special command called attach. So if you have a database open, you can issue an SQLite command to that database that says attach, give it a file name, and then a symbolic name that it'll refer to, and then it'll have both databases open at the same time. And once both databases are open simultaneously, you can do things like joins that use one table out of this database and another table out of the other database. Or you can copy information. You can do an insert into this database from a select out of the other database to copy information from one to the other. So, for example, if you wanted to make a backup of a database, of a particular table in a database, you could attach a backup database like this, delete what was originally in the attachment, or in the backup database, and then copy the information in the main database over to the backup. And because I've done a begin and commit around that delete and copy, this is an atomic operation. So even if you lost power in the middle of your copy, you haven't lost anything. It would roll back to its original state. Here's a little bit of Tickle code that actually goes through and makes a complete copy of the entire database. By consulting the SQLite master table, it knows the names of every other table in the database, and it creates the schema and then copies all the information over there and does it as a transaction. I must have moved the mouse. There we go. In talking to a lot of people, there's a lot of people who've been using SQLite or SQL database engines for a long time and really don't have an understanding of how they work on the inside. You really need to think of SQL as sort of a peculiar programming language. And not many people do this. They think of SQL as a data access language. It's really a peculiar kind of programming language. It's peculiar in that instead of specifying the algorithm that you're going to use to do something, you specify what you want the end result to be, and then let the database engine figure out the algorithm for you. So for example, you tell it, hey, I want certain information from certain tables, and then the database engine figures out the most efficient way to try and access that information. So any relational database engine really can be divided into a couple of pieces. A front end, which takes SQL and compiles it into sort of a little miniature program that's going to access the data, and then there's a back end which actually runs this program and accesses the data for you. And so every relational database has sort of a virtual machine built in. Now, something interesting about SQLite is that the virtual machine is well, I'm getting ahead of myself. So with this in mind, we can revisit the 8 major interfaces to SQLite and interpret them a little bit differently. Before I'd said the SQLite 3 prepare API prepared an SQL statement. Here, think of it as a program, a compiler that's compiling a program to run on the virtual machine. The bind operation initializes certain variables within that program. The step interface is like pushing the little step button on your symbolic debugger. It just makes it go to the next breakpoint. Reset just rewinds the program back to its beginning, and finalize just erases the virtual machine. With SQLite, you can actually get a listing of what the virtual machine looks like. If you put the explain keyword in front of any command, it will, instead of actually running the command, it will return a bunch of rows, which gives you a sort of an assembly language view of what this little virtual machine is doing inside of SQLite. SQLite is somewhat unusual in that it has, when you prepare an SQL statement, it prepares, it generates virtual machine code that looks kind of like, it's bytecode. Most other SQL database engines that I've encountered, their programs are really just a big linked mesh of opaque, well, they're not opaque, of structures. And you have sort of a web, and then you walk this mesh of structures. SQLite actually does bytecode that you can actually view and trace in real time, and which is interesting, especially from the point of view of people who use SQLite for teaching. Key points I wanted to get across. SQLite's a small, self-contained, zero configuration database engine. It's not meant as a replacement for Oracle. It has a totally different role. It's a powerful replacement for things like fopen. Anytime you're writing a program and you're doing fopen to open some little data file, think, well, would SQLite be an appropriate use here? It's a good replacement for GDBM or Berkeley DB because it has the schema layer. A lot of times SQLite has been used as a stand-in for enterprise databases in programs where the full power of an enterprise database just isn't necessary. You get the cross-platform database files, and then there's the issue of the manifest typing, where you can store anything you want into a column of SQLite, and it'll let you do it. So, some observations on my history with SQLite, what I've kind of learned from running this project for the last 6 years. First thing, SQLite's in the public domain, and I've learned over these 6 years that this is not necessarily a good thing from the point of view of the people who use it. I thought that when I was going to release SQLite, the source code, into the public domain, that this would make it easy for people to use it. But big companies, they go, the engineers say, hey, we want to use this in the product, and they get talking to the legal staff, and the lawyers see public domain, and they panic. Oh, what do we do? We know how to deal with the GPL. We know how to deal with the MIT license or the Berkeley license, but this public domain, it doesn't. Apparently, people tell me that there is no such thing as a public domain program in Europe. This is purely an American concept, apparently, and so I have generated an enormous amount of billing for corporate lawyers by placing this in the public domain. I know that one client I had or one company in Europe, they were not willing to accept the fact that this is the program's in the public domain, and so they paid a small token fee to me and the other developers, and made us sign licenses, a perpetual use licenses, just so that they would be covered. So I don't have an alternative of what could be better. I think this is really sort of a political thing, but it surprised me how difficult it would be for people to use public domain software. We saw a picture earlier that SQLite uses a bytecode virtual machine, and there's a lot of programs out there that use virtual machines. I mean, there's Parrot now for Perl, and there's bytecode that runs Tickle, and there's Java has its stuff. And every time I look at one of these virtual machines, they're all stack based. In other words, you push operands onto the stack, and then you do an opcode to operate what's on the stack. And what I have learned in 6 years of working with SQLite that, and I haven't really tested this theory, but my current theory is that a register-based machine with 3 operands is a whole lot easier to generate code for that's optimal. And I would have never guessed. I mean, every time you talk to somebody, they're always wanting to do a stack-based virtual machine because they're so easy to get going right away. But I think ultimately you need to go with a register-based virtual machine. When you write something like a database engine or any kind of complex program and you put it out there for people to use, people think it operates by magic, apparently, because they don't understand why it can't. I solved this problem seemingly by magic. Why can't I solve all of these other problems too that are really hard? And so you get a lot of feedback from people who don't understand how really difficult this is. Can't you just wave your magic wand and make this go away? Where this comes up a lot in SQLite is, and I had a couple of examples that have just vanished from my mind. I'll come back to that. There's this myth that people in the open source community will help you fix your bugs. Not true. They'll help you find them, but you're completely on your own to fix them. I get a lot of people coming in and doing bug reports, and a lot of people are really nice about it. A lot of people are really mean. They're not paying me anything. They're like, why can't you fix this right now? But it is nice to have the people, the many eyes looking at it and finding problems in your code. I've worked with it for 6 years, and the manifest typing idea, the dynamic typing in the database, is, I think, a really good thing. And I know that there's still a lot of people in the world who disagree with this. But if you're one of those people, I encourage you to keep an open mind and give it a try. And I think that after you've used it for a while, you'll find that the dynamic typing is a better approach to doing databases than having a strongly typed static typing in the database. The SQLite that you guys see, that you download from this website, is only about 40% of the source code. Actually, all of the source code is available, but the part that you compile and that you build into your application is really only 40%. That's the C code. The most important part of SQLite is the 60% of the regression test cases that verify that it's working correctly. We've got 98% code coverage on the most recent release of SQLite. And what we found is this has given us tremendous freedom to rewrite huge sections of the database engine from one build to the next. We don't even have to do a minor version number. We can completely strip out an entire system, replace it with totally new code, and as long as it passes the regression test suite, we have a high confidence that it's not going to break anybody's cause any serious problems. And that's, I'd heard people tell me this before I undertook SQLite. SQLite's the first project where I did this kind of high-level coverage and extensive testing, and I was amazed at how well it works. It's a lot more work at the beginning, but it will save you a lot of work in the end. A lot of people complain to me a lot about SQLite is that they compile it on, the latest compiler to come from Microsoft or something, and they get lots of warning messages about, I'm casting a signed character pointer to an unsigned character pointer without actually explicitly stating the cast. And they're really upset about this. Oh, SQLite must be full of bugs because you're casting signed to unsigned pointers without being explicit. And I try to explain to them it doesn't matter. I mean, when has doing such a cast ever created a bug? Why is that warning message even issued? But people get really upset about that, and slowly people are beginning to understand that the regression tests are really much better than doing a static code analysis or finding problems. And finally, the love of money is the root of all evil. My original business plan with SQLite was to give away as many copies of it as I could for free. And this worked really well for about the first 3 years. And then people wanted to start paying me for it, which I was very happy for them to do. I mean, I did not solicit business for it or anything, but companies started coming to me and say, well, look, we want you to make these changes for us, we want you to support it, and so forth, and that worked great. But it's caused sort of a dilemma for me, because In the early days, anybody would come to me with a problem, and I'd spend a lot of time with them. I'd stop what I was doing and help them work through the problem. But now I have all these people who are paying me for support. And so people come to me and they say, and people who are not paying me for support come into me and ask questions, and I'm thinking, well, these other people are paying me. If I help you as much as I help, then that's not really being fair to them. And it created a dilemma here for me. This is not an observation so much as it is a question for you. I'm not sure how to deal with this because I really want everybody to be using it. I want to be able to help everybody. But when software like this gets to be popular and people start using it more, and people start paying for it, it sort of changes the dynamic a little bit. And I find myself not giving as much attention to the people who are not paying me as those that are. And I'm not sure that that's a good thing or a bad thing. It's just an observation, and I'm not real sure what to do about it. I have not kept track of time. I don't know how well my estimate went on 35 to 40 minutes. Am I ahead?
38. So we have maybe
I was dead on, and I said it was going to be, my estimate was 38 minutes and 30 seconds, so assuming we started on time. But now we're to questions. Yes, I'll get to you in a second.
Question and comment. The question is, why choose to lay out the database as table-oriented rather than more object-oriented?
The question is, why did I choose to lay out the database as table-oriented rather than object-oriented? I'm not sure I understand. I mean, it's SQL, so SQL is sort of table-oriented, and I wanted to be compatible. I don't think I've understood your question correctly, though. Since
It's a question I had. Is there an object relational mapping tool that's out there?
Is there an object relational mapping tool for SQLite? I started writing one once, but it never really got very far. I think there are some quasi-commercial packages where just one or two guys get together and put something out on a website, and you can download it and pay them $50 or $100. I've not used them. I can't advocate one over the other. Now, there's an ODBC adapter, and so you could use something like Irwin or something, I suppose, because won't it talk to any ODBC database? Well, any of these object relational mapping tools would, they'll usually talk to an ODBC database, and so you could use it that way, I suppose. You had a comment to go with your question, or did you want to clarify your question a little bit?
Clarify the question. One way to model inheritance is also to use joins.
Okay.
But joins are typically slow.
All right.
So if it were laid out so that the objects were more, all the data is more closer together on the disk, that's fascinating.
Okay, the question was, or the comment was, you can model inheritance using joins, but joins tend to be slow. And you asked, but if things were...
If the layout on the disk were different, so that it clustered the relevant data together, it would be faster.
And so if the layout on the disk clustered relevant data together, it would be faster. Yeah, you may be right. I'm not really following what your point is. So you want to talk to me later, and we can maybe draw some pictures on a chalkboard, and it might become clear. Question here next.
You said in your conclusions that manifest typing was better than static typing.
Yes.
And then you just stated, so based on your experience. My experience has been the opposite. I found many hours wasted because of things that static checking would have checked. So I'd like to hear some examples of how manifest typing is better.
I find that static typing tends to mask bugs. What happens in the problems that I've worked on, what I find is that if you have static type checking, you might have a programmer that's writing some module, and they're supposed to put, say, the Latin long of some coordinate into the database, and then instead they put in two text strings that say hello world. Well, static checking would have clearly caught that because it was looking for two floating point numbers. But you know what? If the programmer has such trouble that they don't know to put floating point numbers in for the Latin long, then just because it forces them to put floating point numbers, they're probably not going to be putting the correct floating point numbers in there. And so I would really rather have hello world in there in place of the floating point numbers, because at least that's going to be easy for me to spot and I can track the error down. What I find is that errors tend to cluster like that. So that if somebody's putting the wrong type of data into a database, yeah, that's a problem, but I can find it pretty quickly, and usually when I'm looking for that, I can find other errors that are approximately related to it that are in the same area. It gives me a place to look. The other thing is that the added flexibility. Usually when I'm designing a schema, I don't know how it's going to be used at the end of the day. If I have to commit to a static type early, and then later on we see that we need to extend the problem or to put different types of data in there, then I have to go back and change my schema, which often involves recompiling legacy applications and so forth. If I've got a dynamic database, I don't have to do that. I just put the new data in and it works. Question in the back.
Is this presentation available online somewhere?
The question is the presentation available online? It's on a little flash stick, and I'll be happy to let you download it if you want. It's all HTML. Any other questions? Does New York have questions? Or here's a question here in the red.
Can you briefly cover saying complex data types? Can you mention that?
Well, yeah, I need to, the question was, I mentioned complex data types. What do I mean by that? I tend to approach a problem by breaking the problem down, and first just what it is that I'm storing. Breaking up into objects. Treat each object. Figure out what your objects are. Each object is a separate table in your database. Each instance of the object is a row in that table. If you store things this way, I do a lot of programming in Tcl/Tk, and Tcl/Tk it's a wonderful language, but it's very weak on data types. Every other language out there is got a bazillion things built in. Tcl/Tk has very little, so it comes in very handy there because with Tcl/Tk we just have variables and arrays and not much else. And by putting a database in there and building that into my application, I can do much more of an object thing where I can have all these different structured tables with fields in them. I'm not explaining that very well, but
I thought my first thought that you were doing something weird with merging objects and shoving them in.
no, I'm actually using the rows in the table as the object itself. That's where I'm storing it, and so that way I get object persistence for free, and I can query large collections of objects without having to hook them into a linked list or a hash table or anything like that. Another question in the front?
You said that you had been using a stack-based virtual machine, presumably with a 1 byte opcode. The question is, you'd like register machines better, you think, now, but you haven't actually done it yet.
I haven't actually done it yet. That's correct. The question was,
How many registers was the real question?
The question was, I said I think that a register-based machine is better than a stack-based machine. And you're right, I have not tested this theory yet. I just noted I've been trying to do some optimizations for a number of years on SQLite, and I've noted that, boy, if I had just gone to a 3-address register machine, this optimization would have been so simple. Some of them I've yet to implement because they're so hard to do on a stack-based machine. In SQLite, the programs are always such that it's a finite amount of memory. And in fact, I can compute, when I'm preparing the statement, I know in advance how big my stack's going to be. So I can always do that in SQLite. I know in advance how many registers I need. That's just the nature of the language that I had. Question?
The authority limitation that they're just scarce but not checked, is that due to some deep issue with the design, or is it something you can remove anytime with somewhere?
It's just, the question is, why do I only parse foreign keys but not enforce them? It's a question of just doing it. A big user of SQLite is embedded device manufacturers, cell phones, MP3 players, this sort of thing. There's a lot of companies that do that, and they give me a little bit of money to make sure that SQLite doesn't get too big, doesn't get bloated, because they're trying to fit their database on this little tiny device. If they can save a couple pennies on a flash chip, that's big for them. And so the foreign keys, to put it in would cause the footprint of the to get a little bit bigger, for one. Of course, we could make it an optional. They could leave it out at compile time, and that would solve that problem. And that's probably what I'll do eventually. The other thing is that I have not personally needed it, and so I haven't been real motivated to put it in, and so it just hadn't happened yet. You know, as soon as I have a personal need to have foreign keys, I'm sure you'll see them come in pretty quick. Any other questions? Questions from New York?
What isolation that is?
Serial, it's serialized only, actually. I did some extensions recently that allow you to do read uncommitted, but only under restricted circumstances. It has to be the two connections running in the same thread and some other restrictions like that. It's used by the embedded device people because they wanted something less severe than serializable. But by default, you only get serializable. Question?
You mentioned it's in memory, or
It's you can by default. The question is it an in-memory database? Well, no. It's a the database fits on disk. It goes into a disk file. What you can do is give as the name of the disk file that it's going to be using when you're opening it. You can give it an empty string, and it'll just keep it all in memory instead. As soon as you close the connection, it forgets everything. So, but some people, that's useful for cache or something. Other questions? In the back here? Say again? What's the future of SQLite? It's being, a lot of companies are using it in their products. Are you asking where I intend to go with it? What's some new features coming up? We're working on full text search. There's some minor features that'll be going in pretty soon, such as the ability to do incremental reads and writes of blobs. I was really planning to have, coming back to your earlier question, I was really planning to have at least some support for foreign keys in by now, but I've been tied up with some other things and just haven't gotten around to it yet. Yeah, foreign keys and the big thing, in the near term, the big thing is going to be full text search. Longer term, I don't know, it depends on what I need. Other questions? Or let me amplify that. It depends on what I need or what you're willing to contribute. Other questions?
So my previous experience with SQLite, we have to keep a backup ourselves. Because sometimes the database will have open.
The question was sometimes you've used SQLite before and the database would corrupt. Well, it's not ever supposed to do that. So if that ever happens to you, file a bug report or call me and we'll track it down. There have been a few cases, we have found a few bugs in the past that could lead to database corruption, but not any within the past year. And those are very rare, and people use it all the time in situations where they're writing to the database and they lose power. They're using it in devices that don't have reliable power. And when power is restored and the machine comes back up, the write that was in progress automatically rolls back, and we've not had any trouble. We test that extensively. We've got for testing purposes, we have a special back end that we plug in. There's back ends for Unix and Windows and various other. We got this special test back end that we plug in where we can simulate a power loss in the middle of a transaction, and we do lots of tests on that to try and find problems, and it seems to be working. If you know of a case where you're seeing corruption, please let us know, because we want to track that down. Question?
Does rollback when you start your process back up and rolling back, is it pausing during that time? Is it...
No. The question is, when does it roll back, I think is what you're trying to ask. So if you're in the middle of a transaction, you're writing to the disk, you lose power, and the database is halfway updated. Okay, later on you get power back, you come back up. The first process that opens the database sees that it was left in a sort of a halfway modified state. And when it does the open, at that point it rolls back the changes so that it restores it to its state before that transaction began. So that happens when you do the SQLite 3 open. It depends on how big your transaction was. Not normally. Unless if you had a really, really big transaction that you've been running for a long time, it could, in theory, take a little while to do. But normally it'll do it within milliseconds. Question here.
Presume nothing bad happens if you lose power again while you're doing this open.
That's correct. The question was, suppose that you lost power, in the middle of a transaction, power came back up, you're starting to roll it back, and then you lose power again. That's correct. You can take multiple power losses, and the next time it comes up, it'll start over again from the beginning, trying to roll it back yet again. No more questions? Thank you all for coming.